The first thing I want to review is section A6, which is rational expressions. Those are fractions. So rational expression is a polynomial divided by a polynomial for us. And so normally you would say this is a fraction. It needs to be a little bit bigger. And examples would be x minus 2 over 4, 4 over x minus 2, x over x squared minus 1, and complication, x squared plus 1 over x squared plus 2x minus 3. A complex fraction would be a rational expression over a rational expression, or would be a fraction over a fraction. An example of that might be something like this: x plus 1 over x divided by 1 over x plus 2. You've got a fraction in the numerator, you have a fraction in the denominator. It's a fraction divided by a fraction. So we're going to start off with just the simple ones in terms of multiplying fractions. If you remember, to multiply a fraction, you would take something like 2/3 times maybe 5/6. If you multiply across. This becomes 2 times 5 over 3 times 6. You could reduce first if you wanted to. And this becomes 10 over 18. Reduce it down, common factor of 2 definitely. So 2 divides 10 5 times, and divides 18 9 times. So this is 5 divided by 9. Okay. And in arithmetic, that's how it works. I could have gotten to the same place by saying, well, 2 divides 2 once. Since this is a multiplication, this becomes one entity. 2 divides 6 3 times, then multiply across. You would have gotten to the 5/9 that way. In arithmetic, it's easy because numbers can be reduced down nicely. Algebra, you don't want to multiply it out. You want to reduce, you want to simplify first. Well, if I'm going to do a algebraic expression, first thing I want to do is I want to factor both entities. So I'm going to be looking at doing a factorization. So the factors of the numerator are x plus 3, x minus 2, and of the denominator is going to be x plus 1, x, oops, excuse me, it's not x plus 1, it's x minus 1, and then x plus 5. And you can see nothing could be reduced down there. This is the difference of squares, so this is x minus 5 times x plus 5. And then the denominator is going to be x plus 5 times x minus 3. And then you see if anything reduces out. Well, you notice that x plus 5 reduces out with the x plus 5. And then nothing else. See, remember, either the whole set of parentheses goes or nothing goes. So in this case, what I'm going to be left with is a mess, which I'm not going to multiply out because I'm too lazy. And that would be x minus 2, x minus 5, divided by x minus 1, x plus 5, x minus 3. Welcome to the world of college algebra, because it's lots of times we end up with problems like that. Now, question is, why wouldn't I choose to multiply that out? Well, one of the main reasons why you would choose not to multiply it out is because this is usually part of a larger problem. And when you take it to the next step, you're going to combine it with what's next. And then you'd have to factor it back out again. And I don't know about you, it's just too much to multiply out. If I could FOIL it, I'd be happy. But if I have to now multiply 3 factors together, forget it. That would be my most favorite thing to do. Any questions? Now here's a division. Now if you remember, essentially if I'm going to divide, this is essentially the same thing as saying, let's take 9x squared plus 3x minus 2 divided by 12x squared plus 5x minus 2. Divide that by the denominator, which is 9x squared. This is a complex fraction. 6x plus 1 over 8x squared minus 10x minus 3. That's essentially what it's saying. Now, if I were going to divide two fractions, remember what you do. If I would take 1/2 divided by 3/4, this is 1/2 times 4/3. I would invert the divisor and multiply. This would give me 2 divides 2 once, divides 4 twice. Multiply across, you would get 2/3. So there's no difference between division of fractions in arithmetic and division of fractions in algebra, except you got all these variables running around. So my step in this particular instance would be to invert and multiply. So this then would be 9x squared plus 3x minus 2 divided by 12x squared plus 5x minus 2 times, invert this guy, and you're going to have 8x squared minus 6x, or minus 10x, minus 3, and 9x squared minus 6x plus 1. And now you've got a problem just like the one above, where now, essentially, anytime we have additions and subtractions, this forms a grouping. And the only way you can reduce anything out is to get somebody to separate from the group, which is what factorization does. What factorization does is get that separation from the group. Okay, so we need the factor, and that's when we hope for the best. And my primary concern with you guys and coming out of intermediate algebra is you tend to be a little weak in factoring. We have to work on that. For those of you going forward, it's going to become of paramount importance that one thing you can do is factor. And if I had to look at this guy, normally it's a 3 and 3 situation. It's usually not 9 and 1. Notice these are fairly small numbers. So if I'm going to use a kind of a working at it, the fact that this is minus says that the signs in the parentheses have to be different. One is going to be plus, one is going to be minus. That's the only way, because if you multiply the last together, they've got to be of opposite signs. Right? That also means that when I do the inner-outer product, because one's plus, one's minus, it's going to subtract. So in order for that to happen, you need the numbers to be smaller. And I always look at, when I look at my choices for 9, that's going to go in the parentheses, it's either 9 and 1 or 3 and 3. You always usually start with the smaller numbers first. Or what I do sometimes too is I look at one of them and I say, who's going to be the easiest to break down? Because if we're looking at reducing this fraction, that means it's got to have common factors. So if you look at one of them and say, well, that's easy to factor, I got that one. Then you do him, and then you look to see, does one of the others have that thing in it? Yes? Okay.
Would 3 be a number that would...
Yeah, and if you notice, well, there's a 3 here, there's a 3 and 4, right? And there's a 3 and 3. What's the chances that essentially this guy's going to factor into a 3 and a 3? Because there's common factors of 3 in each of those 9s, in each of those numbers. So So if I look at this as being a 3x and a 3x, 3x times 3x is 9x squared. How do I get a 2? Just a 2 and a 1. Well, this is good news here. This is the same. So it doesn't matter where I put the 2 and the 1. It's going to matter where I put the minus sign. So this would be a 2. This would be a 1. And that says I need a plus in the middle. Well, this is going to be a 6. This is going to be a 3. Who's bigger? The 6. So this is going to have to be a plus to give me a plus 6. This is going to have to be a minus to give me a minus 3. Now, this I'm not sure. This could be a 3x plus 2, maybe. Well, why would I say that? Well, this is a 2 and 1. That's the only way I can get a 2. And this has got a 3 in it, like a 3 and a 4. But I'm uncomfortable with that, so I'm not at all sure if that's going to be the case. However, and it might well be, because if this is a 3 and a 4, this would be could be a 4 and a 2. But this guy here is for sure a 3 and a 3. Signs are the same because this is a plus. They're both minus. This would be a 3x and a minus 1 and a 3x minus 1, and that matches with this guy right here. Now I'd look at these two and say, who's going to be easier for me? And neither one, quite honestly. So I'll have to make a choice and play with it. And if this is going to be a 3 and a 4, and I don't know because there's that 5 in the middle. They have to subtract, and I have to be careful where I put the 2. And so what I'm looking at is a pencil. Pencil with an eraser would be nice. A pencil and a pencil with an eraser. So, yeah, because I try it out here. And I know my choices are 2 and 1. Well, if I put the 2 here and a 1 there, I need a 5 in the middle. The question is, I've got to subtract 8 and 3. 8 minus 3 is 5. And I didn't think of it ahead of time. I just put numbers down as I thought they came in my little puny brain. By the way, if I flipped them, right, I wouldn't still have the right number. I wouldn't have the right number. If this were a 1, I'd have a 4 and a 6. Then I would have flipped them and then tried it the other way around. So this is a 2. This is a 1. Now I need to set the sign. I need a plus 5. So there's an 8. There's a 3. The 8 has to be positive because I need a positive 5. And this is negative. And look at that. That matches this guy up here. Now that tells me that this guy is probably 4 and 2, right? So 4 and 2. Would be nice if it'd be a 4x minus 1. Don't know. 3 and a 1, I need a 10. Well, I can't, if I put the 3 here, that's 12. I put the 1 there, that's 2. 12 minus 2 is 10, because this has got to be a minus. Now I need to set the sign. I need a minus 10. So that means this 12 needs to be negative. And look at that. These two are not going to go. Now, if I would have written the problem, I would have made it go away. But who am I? I don't write these problems. I would have made that a positive 10, and it would have flipped the signs, and everything would have canceled out nice. And well, I guess the factorization was bad enough. So now, I've got all parentheses. Remember, a multiplication just brings this under a single line, and now you just reduce out things that aren't common. That's a 1. This is a 1. And that's it. That's all she wrote. 4x plus 1, now you have to be careful. 2x minus 3. 4x minus 1. 3x minus 1. And nothing else can go because either the whole set of parentheses goes or nothing goes. So you're in an all or nothing situation.